In this video, I'm going to show you how to create an op-amp linear macro model. Then I try to create a subcircuit and try to do a basic simulation confirming the model. Here is a picture of a linear macro model for an internally compensated op-amp with finite gain and bandwidth. As you see, the gain constant A0 D of the voltage controlled voltage source ED corresponds to the differential gain of the op-amp at DC. A typical value is 10 to the 4 or 10 to the 5. Resistor RB and capacitor CB form a single time constant. The values of RB and CB used in this macro model are chosen such that FB corresponds to the 3 dB frequency of the op-amp being modeled. The voltage controlled voltage source EB with a gain constant of unity is used as a buffer to isolate the low pass filter from any load at the output of the op-amp. This linear macro model can be further expanded to account for other op-amp non-idealities. For example, the DC voltage source in series with the input terminal models the op-amp input offset voltage. Now I'm going to realize this in the LTSpice simulator. First, I have to make a new schematic, and I need to find different components. All are straightforward. The only thing I want to add is that E in the component represents the voltage controlled voltage source. Let me complete the circuit. Now I have to assign different values. Let the offset voltage be 1 millivolt. The input resistance 2 meg. Gain of the voltage controlled voltage source 10,000. The filter resistance 16 meg or 10 meg. This capacitor 1 nanofarads. This gain, it should be 1. The output resistance, let's assign 50 ohms. Click on OK. Okay. Let me just label input and output nodes. So N plus for this one, N minus for this one, and out for this. Here you go. The circuit is completed. Now I want to make a symbol out of this circuit. First, you need to save the schematic somewhere. Okay, let's save it, or let's use save as in the desktop. Let's name it op-amp model. Yeah. So let's create a symbol representing this schematic. Click on File and New Symbol. So you can draw any shape for your circuit, but it's much better to have a symbol showing the circuit function. Here, for instance, we have an op-amp, therefore I need a triangle. I use a triangle to show the function. Let me just draw it. This is a little bit off grid, so I have to adjust it to be on the grid. So please delete this one and again redraw the symbol. Okay. Yeah, this is fine. Yeah, so you can insert some text to show the input and output pins to ease its usage in the top level simulation. So to do so, click on Draw and Text. So in plus, we can put it here, and in minus, we can put it here, and out. Let's place it here. So of course, you can change the size of this. Let's make it 1. Now, what you need to do is to assign pins or ports to this circuit. So click on Edit and add pin or port. And then you should write the pin name, same as the schematic labels. Okay, so we had in plus, click on OK and place it right here. Again, I have to add the other one, in minus, okay, and out. Okay, so now we want to test this symbol. So first you have to save the symbol in the same location as the schematic. So save as, you can use the same name, op mod, but for this one the extension is ASY. Save it here. Okay, for testing this symbol, you need to make a new schematic, a top level schematic. First, save again this new schematic in the same location as your symbol. Let's call this op mod test. Okay. So then you can find the created symbol in the component. Go here. Here you can change the directory and click on the one containing your new symbol, and here you can see the symbol. So place it in your schematic. Okay. Next, add other components. For example, I'm going to create a non-inverting amplifier with the gain of 10. So let me just complete the circuit. So I want to have a gain of 10. I'll set this 9K, and this one I give 1K. So 1 plus 9 over 1 is 10. And if my input is 1 volt, then I expect to get 10 at the output. Let's add the simulation. A transient simulation is fine. Let's go with transient. So yeah, here we can run a transient simulation for a short duration, let's say 1 milli, and set the other fields. Click on OK, put it here, then click on run. Here you go. So you can see your top level circuit. This is the symbol that is used here, and then the subcircuit. I can probe this point to see the output, and here you go. You can see that the gain is around 10. So you had 1 in your input, and then you have 10 at the output. So basically, and the only difference is just happening due to the finite gain of the op amp. Yeah, so yeah, this confirms the validity of the linear model we used here. Thanks for watching this video.